Let's take a look at the forces that we're going to work with in chapters 4 and 5 and going forward. The most ubiquitous of all these forces, the one you can't escape, is weight. Okay, this bear on the table experiences a weight force. It's the force of gravity, and it's always pulling down. That's one you know about. There's also a spring force. I have a spring right here, and if I stretch the spring, it pulls back. It wants to resume its original shape. So if I take this toy, hang it from the spring, and I pull it down, what happens is this: the spring wants to go back to its original shape, and so it's making an upward force on this toy, and if I let go, the toy goes up, and it was the spring force that caused it to go up. Now it turns out whenever you distort a surface or something like that, it gives a force. So if I take this little disc here, there's some stretchy fabric inside here, and if I stretch this fabric, it's going to try to pull back where it came from. Well, if I take this little toy car and put it on top of this stretchy fabric, what happens is this: it deflects the fabric and pushes it down. But let's think about this. The car is being pushed upward by the fabric because there's a Newton's third law thing going on. The car is pushing the fabric down, and so the fabric is pushing the car up. That's an example of a type of force called a normal force. And in fact, if I put the car on this fabric, you can see that it pushes it down. But in fact, when I put the car on this board, it deflects the board ever so slightly. At an atomic level, bonds are stretching. And so this board is pushing back upward on the car, and so it's exerting what we call a normal force. And it's normal because it's perpendicular to the surface. So that's another type of force that we have. It's the normal force, and it's due to spring forces at an atomic scale. Now another force that's due to spring forces at an atomic scale is a tension force. If I take an object and I attach rubber bands to it, if I stretch the rubber bands, they want to pull back to the original shape, and so they're exerting a force on this iron, and they'll pull it to the side. You know that. But in fact, if I take a string and attach it to the iron, the same thing will happen. Okay, I've attached this string to the iron, and you can see if I pull on this string, you can see it stretches a small amount. And so at an atomic level, bonds are being stretched, and so this string is going to supply a force to the iron, and it's a force we call the tension force. And that tension force will cause the iron to move. And so there really is atomic level stretching which is happening, and the tension force is going to pull on the iron, and it's going to pull it in the direction of the string. Newton's first law says that an object in motion will remain in motion unless it's acted on by a force. Well, if I take this puck and I slide it to the side, it quickly comes to rest. And that's because there's a force which is acting on it, which brings it to rest. What is the force that brings this puck to rest after I slide it? We'll give you some choices. And in fact, this is a force which you're already familiar with. It's the friction force. The friction force between the puck and the table causes this thing to slow down and stop. I can get rid of the friction force by doing this. If I pop the cork on this and let air come out, now I have much less friction, and so then the puck will continue to slide until I lose the air, and then it quickly comes to rest. So friction is another force we want to consider. And there's two different kinds of friction force we want to look at. There's one that's called the static friction force, and that works when I have two objects which aren't sliding with respect to each other. So right now, I'm pulling on this iron with a tension force, but it's not going anywhere. And that's because the static friction force is keeping it from moving. Once an object starts to slide, there's the kinetic friction force. It's a force of sliding friction, or kinetic friction. The friction force makes things slow down and stop. It's a dissipative force. There's one other dissipative force we want to look at, and that's the force of drag. If I take an object, throw it up in the air, it comes back down. And this is coming back down because of the weight force. But if I have a scarf and I throw it up in the air, it comes back down very slowly. And that's because there's an additional force at work. And the additional force at work is the drag force. The drag force. And the drag force is a force you've often called air resistance. One other force we want to look at is this. And this is one that uses Newton's third law. If I take this propeller aircraft and I wind up its propeller, when I let the propeller go, it's going to push air backwards. So if the propeller is pushing air backwards, the air is pushing the propeller forwards. And so this airplane will move forwards because there's a force on it from the air. And that's a type of force we call thrust. So if I let this go, the propeller pushes the air backwards, and so therefore the air pushes the propeller forwards. And so we get a thrust force. There's one other force we're going to take a look at. And this is one we aren't going to use to solve problems in the first part of the book, but in the second part of the book we are. I have some styrofoam balls inside this plastic container, and when I roll them around like this, I develop a static electric charge. So these styrofoam balls have a weight force which is pulling them down, but there's something pushing them up, and in fact, it's a static electric force. It's an electric force. That's another example of a long-range force. That's a force we're going to come back to in the second part of the book. But before then, we're going to solve a whole bunch of problems with all the forces that we've talked about in this segment.